And we proceed to our next speaker, is Irfan Azeem from NOAA.
Yes, so thank you for giving the opportunity to talk about NOAA's effort of utilizing or leveraging GNSS radio occultation observations for enhanced ionospheric monitoring and space weather preparedness. And this talk, I want to acknowledge Sue Wang from SWIPC, as well as Dominique Florell from SWIPC as well. So here's the quick outline of my talk. So I'm just going to introduce and talk about NOAA's requirement for the ionospheric observations, describe some of the ionospheric RO data sources that SWIFC is using in their ionospheric products and data simulation. And then I want to just briefly describe this new effort within NOAA. It's called One NOAA Space Weather Strategy. I really wanted to kind of give a background that which might be something might be of interest to this community, and then discuss SWIPC ionospheric data products that are leveraging GNSS RO, and just finally conclude my presentation. So space weather, which is a growing concern, it poses a significant societal, economic, as well as national security risk, and also poses a risk to health risk for people, especially astronauts, and also if you're flying polar routes on aircraft. So these space weather risks also include risk to several sectors, like electric power grid, aviation operations, especially the planes that are flying in the polar routes. PNT, we've heard about that earlier, satellite comms, communications, human space exploration, and also for satellite operations and other space-based assets. The effect of space weather is one of the 6 critical societal challenges that NOAA has identified in its weather, water, and climate strategy. And that really, the strategy kind of describes, or it identifies some of the high priority activities that NOAA is undertaking, and space weather is one of them, and that's one of the reasons why space weather has been identified as one of the 3 priority areas at NOAA, as well as NESDIS, and that was the reason why NESDIS created a Office of Space Weather Observations that is responsible for managing and also making sure that our space weather observations, we provide sustainment of our current space weather observation, and also enhance our space weather observations to meet evolving user needs. The space weather, enhanced space weather decision support is a national priority, and as identified or as reflected by the 2020 Pro-SWIFT Act, and also by the 2019 the White House Space Weather Strategy and Action Plan. So what's the role of what's NOAA's role in space weather enterprise? It's a multifaceted role. So NOAA is responsible for building capacity to advance space weather observations, services, as well as policy, as identified in the White House National Space Weather Strategy and Action Plan, which was released in 2019. And NOAA's role is also aligned with the Pro-SWIFT, the Promoting Research and Observations of Space Weather to Improve the Forecasting of Tomorrow. It's a mouthful. This was a congressional act that was signed into law in 2020. The second role of NOAA in space weather enterprise is to accelerate the growth in space weather observation, as well as space weather services. And to meet that, or to carry out that role, NOAA is identifying and sustaining key observations would be the fundamental observations to support operations as well as user needs, providing timely, accurate, and relevant model and forecast products to our end users, and transitioning scientific and technological advances through their research to operation to research framework. And finally, we're also supporting growing private sector activities to fill gaps that may exist either in observations or also in other technology areas, especially where we can leverage commercial providers for value-added services and products. And Mark talked about the space for commercial weather data pilot, and that's really what addresses this particular action. And finally, the last NOAA's role is to really integrating approach and collaboration between research and operations. And that's in that area, we're really looking for applied research. And that's where I think the One NOAA strategy really tries to develop a plan how NOAA as an enterprise is going to support this applied research collaboration between NOAA as well as other centers and the universities. So before I talk about how NOAA is utilizing GNSS RO, I want to kind of quickly talk about the requirements that we have. This is something that Erin alluded to. She showed the coral requirements. So this is our Space Weather Next program objective requirement, which is derived from coral. And here I've shown on the top table, I'm showing the requirements for electron density profiles. And on the bottom, I'm showing the requirements for total electron content. And again, if you're eagle-eyed reader, you may see that the requirement for latencies that shows here at 60 minutes, which actually is old. It's latent. I think we're in the process of updating a requirement. This should read as 30-minute requirement for our threshold and a 5-minute for our objective. So there's plenty of radio satellite missions that have RO capability, and SWIPC is utilizing Ionospheric RO from Cosmic 2, Formosat 7, Aspire, and Planet IQ. So here's just a quick recap of Cosmic 2. We are all aware it's a 6 satellites constellation. And at the bottom, we have Aspire and Planet IQ. Planet IQ is in sun synchronous orbit. They're all of those 3 constellations are tracking multi-GNSS. In addition to GNSS RO, SWIPC also utilizes ground-based GPS receivers in producing products for ionospheric users. So they use GNSS receivers on the ground with a 30-second or 1-second sampling rate. And they're utilizing those ground-based GNSS receivers for TC, S4 and sigma phi calculation, as well as rate of tech index as a proxy for S4. And where available, they're also utilizing ground-based GNSS networks for scintillation, direct scintillation observations at 50 or 100 hertz samplings. And this figure here shows the red dots represent where those ground-based GPS receivers are located that SWIPC is using in their products. As I mentioned, the SWIP's space weather is a growing concern. NOAA responsibility is to build a nation that's ready and resilient to space weather event. However, if you look at NOAA as on an enterprise level, space weather applied research is lagging some of the other research areas or some of the other domains. So we have identified that that's a key area where NOAA needs to improve. So that's where we have created and released a One NOAA space weather strategy. And the goal of this strategy is to really foster cross-office engagement, alignment, and commitment to NOAA space weather enterprise, and to prioritize and advocate for NOAA commitment and investment in space weather research and infrastructure, and use this One NOAA space weather strategy to develop a cohesive and compelling vision for a space weather applied research program that cuts across NOAA. And this One NOAA space weather strategy was developed in coordination with several line offices within NOAA. So it's NESDIS, is one of the core team members. National Weather Service is part of this space weather strategy, as well as ocean and atmospheric research. So it is truly a cross-line office effort that cuts across different offices within NOAA to develop a plan that will support applied research in space weather. So let me just quickly mention that this strategy has identified some key areas or key focus areas, and data simulation is one of the key focus areas for One NOAA strategy, and integrating Ionospheric RO is one of the key priorities for this One NOAA strategy team. So let me now quickly show some of the products at SWIFC that operational products or experimental operational products that are using Ionospheric RO data. On the top is rate of tech index that's utilizing ground-based GPS receivers, but on the bottom, let me see, is Cosmic 2 and commercial scintillation products. So we have All Clear Map that I believe Mark also alluded to, that kind of gives you where one would expect the scintillation is not happening. This is something that is the geolocation of scintillation is currently being developed. It's not currently operational. Bubble Map is going to be released hopefully soon. Limb to disk, that's another product that's being currently worked on. GlowTech is assimilating ground-based receiver as well as ionospheric RO from space-based assets. And here on the top right, it's the GlowTech TEC map that shows total electron content over a course of the day. And then the bottom, it shows the difference between TEC on a given day from the 30-day running mean. And you can see there are differences when that kind of shows you the variability in TEC, day-to-day variability. That's what the difference really shows. So I think Mark has already talked about this, so I'm just going to skip this. And so these two figures shows you the impact of assimilating space-based ionospheric RO data into GlowTech. So on the left is the TEC, global TEC, and you can see there's a really smooth structure, which are not captured by space-based ionospheric RO. So when you do assimilate ionospheric RO from satellite, you start to capture or resolve some of the smaller scale features, which is important for some of the end users. And since I'm running short on time, I'm just going to quickly talk about that again. Assimilating ionospheric RO data, it reduces bias in the GlowTech model. I'm not going to talk too much about it, but I just want to conclude that, again, if you look at space weather, it's still data starved compared to, let's say, the terrestrial atmosphere. So data are needed to accurately capture and resolve some of this pertinent features that are present in the ionosphere. And that's where I think Ionospheric RO can provide us the global coverage of ionosphere that is really needed. And recent studies have actually shown that there is a need for global observing systems to improve not only the ionosphere, because if we assimilate ionospheric observations into our model, some studies have shown that it also helped improve some of the thermospheric density specification, because the neutrals and the plasma in the ionosphere, they are coupled through collision. So having a global observation from a RO, I think, is very important for improving our ionospheric data products. And with that, I'll stop here. Thank you.
We have time for very, very short question. Paul?
So if you go back to that slide, a few back, that had the, like the space weather products, the assimilation. Yeah, so just a comment. So geolocation is operational.
Oh, yeah.
It's the product that underlies the bubble map,
Okay,
okay? And limited desk is, I don't know, it's not operational, but there's been some improvements in that area recently. We'll be briefing those sometime soon.
okay, great. So we're looking forward to getting that operational, yes.
Thanks, the speaker again. And we proceed to our next speaker, shipping